Howdy and welcome back. We'll continue our discussion with when do we pass arguments by reference. So far, we've seen the idea of pass by value, which results in a copy, then pass by reference, in which the parameters refer to the arguments bound to them. So, when do we pass arguments by reference? As shown in the swap function, when we would like to modify the arguments to which the parameters are bound, that's one reason. Another would be to avoid copies. Some objects in our program can become very large. Think a standard library vector housing a lot of data. Each time we pass that to a function, a copy would ensue. And a lot of times we might just like to pass by reference to avoid that copy. There are other objects which we will encounter in the C++ language, such as the IO types, that cannot be copied, so they must be passed by reference. And if y'all remind me when we start talking about classes, I can go over how one can prevent objects of a specific type from being copied to an extent. So avoiding copies. Let's go ahead and take a look at two different versions of this code. So we have on the left here, A is going to be a function f whose parameter is going to be a single vector of integers. On the right, for B, we have the same function f, except the parameter is a reference to a vector opposed to simply a vector. So in the instance on the left, we're passing vect by value. On that in the right, for B, we're passing by reference. So let's look at the implication of this. So let's assume that we're over in main somewhere, and we have our vector of integers. It's named numbers, has the values 1, 2, 3, 4. Cool. Let's go ahead and call f on numbers and assume that we're using definition A. So in this case, we have numbers, which is a vector of size 4, and it looks like this. Cool. So now we're going to go ahead and call this function f. Now notice all we're doing here is kind of looking at the data. You could think about this as maybe computing a sum, computing an average, who knows, but all we're doing in the body of this function is iterating through and looking at each element. In this particular case, we're outputting them to standard out. Nothing special, but again, the key is we're interacting with the data, we're not actually modifying it. So in this case, vect is a copy of numbers. So notice we now have two copies alive, and all we wanted to do was look at the contents of vect. This copy seems a little unnecessary. It seems like we could have, instead of pass by reference, to completely avoid this unnecessary copy, which doesn't even get returned. So it's not like we're even changing these, applying some sort of operation to these values and changing this vector as a result. It's just getting disregarded when the function returns. So that seems a bit like a waste. Let's go ahead and look at function B. Similar setup over here in main. We've got numbers. It's going to be a vector, 4 elements, 1, 2, 3, 4. Okay. Now we're going to call function f on numbers. So in this case, f is called, we transition to the function, and we begin initializing the parameters. In this case, vect is a reference. It's simply another name for numbers. We go ahead and iterate through vect, print out its values. Maybe, in a different application or context, we might do something a little more interesting, and then we return. Notice here, no copy was made, and in this case, we completely avoided the unnecessary copy by passing by reference. The copy was just simply unnecessary. So why even, go through the hassle of creating one? So passing arguments by this vanilla reference should generally be avoided though. And I'll show you why here in a second. This can lead to obscure bugs when you forget which actual arguments are changed through the parameters. For instance, if you have some references, some values, copies, you might start changing things, forgetting that one's actually bound to something that lives outside and has an implication that will exist far beyond the scope of that function. So instead, what we'd recommend you do is use reference to const when you are passing large objects and would like the benefits of pass by reference, so no copy, but do not need to actually modify the arguments. So notice here, all we've said is that vect, our parameter, is a reference to a standard library vector of integers that's constant. In this case, vect is read-only to this vector. We're not making a copy. It's the name for whatever argument is bound to us, but there's some access control. It's read-only. So let's just look at this perhaps silly example. Okay, so we're, I don't know, maybe just printing out the contents through this silly function f. We pass in some sort of vector. So I'm looking at the one here right now. And we're passing by plain vanilla reference. And, we're doing it because we definitely want to avoid that copy. So we iterate through each element, print it out, and return. And at this point, this is why the bugs can be pretty obscure, is because you've just verified the contents of that vector. Your assumption probably when this function returns, if it was a simple print function or writing out to a file, if you open it and verify it, or you look on screen, you're probably going, okay, well, after this function, everything looks good, so maybe the bug's elsewhere. But you forgot that you inadvertently had an assignment here at the end. And since vect is passed by reference, you've actually mutated the vector element at location 1. Oops. So one way to avoid this is when you want to have the benefits of pass by reference, but you do not want to have silly things like this happening where you're inadvertently messing with those parameters, is to simply pass by constant reference. Then in that case, where you attempt to inadvertently modify the contents of the object bound to the parameter, you'd receive a compiler error when you go to compile this. And you would know immediately, you couldn't even run the program, that you had to go correct this and that something was off. So in this class, we're always going to prefer passing by constant reference because a lot of times it is going to be to avoid unnecessary copies. And we'll show you maybe a better way to go about it if you truly need the plain vanilla reference to implement something such as a swap function to make it entirely obvious that, well, I guess in this case, the name would be really communicate that the operation's actually occurring, but we can add an additional level of kind of security, if you will, on top of it to really emphasize that the parameters or that the arguments will be changed within the scope of that function call. And we'll show you that in 1 second.